on this computer. Okay. Uh, Today we have another important lecture, which is the convolution. Now, in this lecture, we are going to talk about the convolution and how we are going to implement different algorithms. These algorithms will be very simple to be implemented on a PC. Now, let's start with the beginning, and then we have three techniques. We are going to discuss the three techniques, which are the direct convolution table, linear time invariant form, and finally, we have the matrix form. And then we are going to talk about the deconvolution and the correlation. This will be the title of this lecture. Of course, this lecture will be included in the midterm exam, okay? Now, starting with the linear system, as you know, when we talk about linear time invariant system, we said that every system will be characterized by the impulse response. Look please at this figure. Here we have H, which is the impulse response of the system. Now, how we are going to measure the impulse response of the system? Look at this, it's very important note, okay? For example, you have an equation. Say the equation will be y of n equals to x of n plus 2x of n minus 1 plus 3x of n minus 1 plus 0.5x of n minus 2 n minus 3 and so on, okay? So we have y, which is the output, and input is the x, okay? Now, if we are going to substitute the input x by delta function, at that time, we can measure what? We can measure the impulse response of any system. Look please here. Here we have a system which is characterized by input-output equation. Well, now, if you are going to feed the input of the system by delta of n, then the output automatically becomes what? Becomes h of n. So in the equation of, the difference equation, y of n, for example, y of n equals to, say, x of n, or let me go to the whiteboard better. Yes. Well, substituted by delta of n, at that time, the output will be what? Will be h of n. Now, let's go to the next slide up to make the whiteboard ready. Now, in many practical applications, we sample our analog input signal in accordance with the sampling theorem requirements and collect a finite set of samples, say L samples. Of course, every time when we are going to work with the discrete time signal or digital signals, we are going to collect a specific set of samples, okay? Specific set of samples. So what we are going to do now here, we are going to calculate the time required to collect L samples. Look please. Now here we have L samples to be collected, of course, starting from 0 and ending with L minus 1, okay? Now, TL will be LTS, okay? TL will be LTS. Well, so the time represents what? The amount of samples to be collected multiplied by what? Multiplied by TS, the time for one sample, okay? This is the way by which we can calculate the time required to collect L samples. Well, now where T is the sampling time interval related to the sampling rate Fs 1 over T, conversely, we can solve for the number of time samples L contained in a record of duration TL seconds. So L will be TL by Fs. So in this way, we can what? We can determine the L. Okay. Now, the L collected signal samples, say x of n equal to 0, 1, up to L minus 1, can be thought of as a block. Of course, from now on, we can imagine that this signal is a single dimension array. Well, so here we have x, variable x, equals to x0, x1, up to xl minus 1, which may be then processed further by what? By a digital filter. It's not working. Yes, we have the same problem.
دكتور
داونلود
الو دكتور
بله
ايش داونلود بعد شيء 3 اير استعمال كي اير بلاير رغبه هكا ايباد تا ولابتوب تا نفسي واي فاي بدي شولي
اي سي نفسي اي واي فاي
هو شنو كافاكي 3 توصي اير بلاير دي كونكت
بله او لازم بايباد جديد بس كان حكينا اوكي ابيدي
كانسل كاي
انا بلاير بس اي من نجرب عند دراستي باول جاره
بس ده بس ايباد بك ميرور هلكه
ميرور
بله ميرور هلكه او نو سيرش شيب ريو اير بلاير
اري 3 يو اير بلاي ديسكتوب
بله سيدا هايد بانل بني او ديكه تحديد هايد بانل برغبه
برغبه ايه
دبل كليك ده ما ظبط فيجا
ايه اوكي از جود درسته اوكي نو بس بدي خبدن ما هي بس افتشتها هي ملاحظه ميتين اوكي من قلت we said that any system will be characterized by the following. Look, y of n will be say ماشي ايه دقة الايباد مشكلة من هي دقة كي ابيدي كم ماشي ايه اوكي
سيد شيء سلبت بينك يا روتيت دروس كذا روتيت
دقيقة
روتيت بل سري ديال سيد روتيت كليك على ما تشوفي ده بانل بتاعه
نكاز شو الكدرست
روتيت كذا سيدا هذا روست
لا والله شنو الشيف
دجوري ديك
دقيقة أري جهر شو الكذا اوكي على كل من قال لك ملاحظاتني انا ابرو بس بالله بس ما تشتهي مشكله يا هاي ايه والله دي واقفه مسات اوكي جماعه بالي خوبدن for example we have a system which is characterized by y of n okay equals to say x of n minus 0.1 x of n minus 1 plus 2, for example, x of n minus 2 plus 3, say x of n minus 4. Okay, now this is a difference equation. This is called a difference equation. Well, now this difference equation really characterizes the relation between input and output. Now, if we are going to determine the impulse response, I mean edge of n, what we are going to do, we are going to substitute each x by delta of n. I mean x of n equals to what? Delta of n. When x of n equals to delta of n, at that time, y of n becomes what? Becomes edge of n. okay, becomes edge of n exactly. Well, so you have to keep in your mind something. This important note. I mean, when you are going to measure the impulse response of any system, we have to what? We have to substitute the input by delta function to determine the impulse response of that system. Of course, convolution will be utilized for what? To determine the output of a given system. Well, now continue with what we have said before. We said that X will be stored at what? As a single dimension array. Okay, X will be stored at single dimension array, which may be then processed further by a digital filter. Of course, when we talk about edge of n is exactly what is a digital filter. Well, so it's a digital filter. Well, now let's go to the convolution process. Really, we are going to discuss three kinds of convolution techniques. First one will be the direct method. Before we're talking about these techniques, as I think you have familiar, you have studied, as I think, the convolution in using the graphical way. No? Part أنا ورقت ويدي convolution.
بل لسه ما ورقته ما ريكورد هردو ريجيجي ورقت ده صانع هي.
Okay. Now we are going to talk about these techniques, and then we are going to use the deconvolution. The deconvolution you ورقت deconvolution.
بس convolution ما ورقت.
Okay. قلب صنعها إن شاء الله. What we are going to do in the convolution, we are going to fix one function, and the other function will be what? Will be flipped and shift. Okay. Now, for example, in the first summation, means we are going to fix edge and flip x and translate it. Okay. Here, in the second one, we are going to fix x and flip edge and shift. Okay. You are free either to fix h or fix x. Well, now here we have the modification. Look, an alternative way of writing these equations, called the convolution table form, is obtained by noting that the sum of indices edge of m and x of n minus m is, if you are going to add these two indices together, so the final result will be what? Will be n, okay, in the convolution sum. Therefore, the previous equations, this will be the previous equation, can be written in the form of y of n. Look, please, y of n becomes summation edge of I multiplied by x of j, okay? Here we have multiplication between x edge of I and x of j. But we have single condition. We have to obey this condition, which is what? I plus j must equal to what? Must equal to n. Okay? I plus j must equal to n. Now, for example, I'm going to calculate y of 2. Look, please, I'm going to calculate y of 2. So what are the possibilities for the y of 2? For example, it will be edge of 0, x of 2. Nah? I plus j, 2. Edge of 2, x of 0, again, this is another one. And edge 1, x1. Well, so we have three terms in this way. So we have to what? We have to take the possibilities of that number. For example, we said that if you have 2, then the possibilities for ij will be 0, 2, 2, 0, and 1, 1. That's it. If you have 3, of course, if you have 4, 5, and so on. Now, consider a causal FIR filter of order m with impulse response edge of n from 0 up to m. It may be represented as a block, look, edge 0, edge 1 up to edge m. Its length will be what? Will be m plus 1, okay? Length of edge, as you know, we are starting from 0. So, and ending with edge M, of course, the length will be M plus 1. Well, again, you have to keep in your mind this equation. This equation is very important. Ly equals to Lx plus Lh minus 1. I mean, the length of the output, how many coefficients we have in the output, will be Lh plus Lx minus 1. Again, we are going to utilize this equation in next coming slides. Well, okay, now we are going to talk about what? About the convolution table. Convolution table. Note how each output y of n is the sum of all possible products hi xj with I plus j equal to n. This leads directly to the convolution table. For example, now look please, if you are going to follow this technique or this method, we may calculate single output only. For example, I'm not interested to calculate all outputs. I mean, for example, I need to calculate only Y5, okay? Only the Y5. Now look at the possibilities to generate Y5. It will be H1X4, H2X3, H3X2. Of course, we may have what again?
H4X1.
H4X1, but in this example, we are dealing with what? H0, H1, H2, H3, okay, up to H3. We don't have H4, therefore, we haven't added the H4, okay, good. So Y5 will be generated by 4 terms, okay, if H consists of 5 elements. Well, the required computations can be arranged in a table as shown in the figure below, with the filter edge written vertically and the input X block horizontally. Let's go to the table and I'm going to show you what's going on. Look, please. Here we have H0, H1, H2, up to H3. So how many number of coefficients we have? 4. X0, X1, 2, 3, and 4. Here we have 5 coefficients. Of course, if you are going to follow the previous equation, when we talked about the length of the output y, Ly will be Lh plus Lx minus 1. So 4 plus 5 will be 9, minus 1 will be 8. So we can expect that we have what? We have 8 y coefficients, okay? 8 coefficients for the y. I mean, y0 up to y7. Well, now how we are going to construct this table? It's very simple and easy. Just we are going to multiply H0 by what? By the coefficients of the X matrix. Look, H0 X0, H0 X1, H0 X2, H0 X3, H0 X4. Now the first row is finished. Let's go to the second row. In the second row, we are going to multiply H1 by the whole coefficients of X again. So H0 by X1, X2, X3, and X4. The same thing for the other 2 coefficients of H, which are the H2 and the H3. And in this way, the table, convolution table, is constructed simply and easily. Well, look please. Now what we are going to do, now we are going to add the elements in the diagonals. Look. So Y0 will be H0, H0, X0, okay, this one. Then Y1 will be H1, X0, H0, X1, okay. Y2, this will be the Y2. This will be Y3, Y4, Y5, Y6, and finally we have what? We have Y7, okay. As I have told you before, we said that the length of Y must be what? Must be 8 elements, no more. Now, here we have a numerical example. So you have to, at home, try to do this example by your hand, really, okay? Calculate the convolution of the following filter and the input signal. Of course, edge represents what? Represents a filter, digital filter. Well, and X is the input. and convolution will lead to determine the output of the filter. Okay, solution: the convolution table with edge arranged vertically and x horizontally will be the following. Look, 1 by the whole element will be 1 to 1 and so on. 2 by the whole elements minus 1 by x and 1 by x. In this way, we have what? We have constructed the convolution table. Again, we may measure the elements in x 1, 2, 3, 4, 5, 6, 7, 8. 8 ها؟
قلت أو 8 ولا 4
بالضبط، يعني همي شندن دوازدنا. نا. Okay, 12 minus 1, 11. So y will be 11 elements. Okay. يعني بدنا يوزده 11. 1 2 3 4 5 6 7 8 9 10 11. بلي كرمك.
يعني سيدة بس ثابتة؟
ثابتة دائما وابدا ظني ما هي length of y equals to lx plus lh minus 1 دائما.
بلى سيدة بس قيمته يعني يصل دبر انه كا حطوه حفته وانا
او يعني example بري example
بلى سيدة حطوه حفته
انا باكزامبل بوشي بري خبده الفيري ما هي بينج element ابو اكسي وشار قيمتها ابو اتش شبه هندي بينج بشار دي بنتشان نه minus 1 هشت الفيري
يعني سيدة يعني
ايه
عفوا سيدة يعني سيدة مقصدهم مثلا يعني كنت داس بك تدخل واي نوت وانا
اري واي نوت I'm just picking why not اري I'm just picking why not اري
درست سيدة.
Okay. Now what we are going to do now we are going to yes now this represents what represent y not أبا قيمتي y not شندا 1 أبا شيء y1 2 plus 1 3 okay أبا شيء تشتا أبا y2 minus 1 plus 4 3 again okay and so on diagonally you are going to what you are going to add the elements in each line okay of course you have to be aware of what you have to arrange your elements okay arrange your elements to get what to get accurate results look very خبدن 1 and minus 1 to be what to be 0 1 well 4 minus 1 3 and so on okay of course you have to do that at home okay to be able to determine the values well discard I'm sorry yes
سيدو
بلي عزيزي
سيدو بس الويري واي شو ريبريزنتد كتن
شاو
يعني واي وكيف ما درت كابت مونا او رقم حميد در كتنا بما او شو ريبريزنتد كسيدو
شو ريفرنس يعني شو مقصد الريفرنس نظام مقصد
ريبريزنت سيدو يعني بما يعني شو بما ديورت كتن
يعني سيدة إلى ماذا يشير؟
شيء الظاهر يعني شيء كردي الظاهر شد بيجي بس يعني
سيدو يعني بوتشي سيدو أنا بوتشي نكاف استعمالت كين
قلت أنت أول ما أختي ما دست كن قلت أنت convolution financial is the output of the system output why system output output يعني انت هاي input x وimpulse هذا system edge اوكي واوتبوت تشتا واي هذا واي ما حسبك بالي خب اول سلايد هذا اول سلايد بس هيك دقه هذا طبعا input x هذا output y وهذا h اوكي يعني بريكا convolution بدي احسب كي output of the system هذا فايدوي
استاذ بس هاي الصفحه اللي بعد اول صفحه
بلى
ثاني صفحه
بس
أوكي. ثاني صفحه
نعم هذه هاي ثاني صفحه ايه تفضلي
لا اللي بعد هاي
اللي بعدها
هاي ما فهمتها لا هاي
هاي ما فهمتيها هاي كلش بسيطه قلنا ايش قلنا راح نجمع مجموعه من العناصر يعني L elements، يعني طبعا عندنا مثلا على سبيل المثال مثلا عندنا 10 قيم راح نجمع. اوكي، كل قيمه الزمن مالها ايش قد؟ تي. فاذا الزمن الكلي ايش قد راح يكون؟ 10 تي. اوكي،
يعني
which is what
القيمة
L multiplied by what by the time for single sample. وقت x sample اي كندا نتي اسا ها
بلى
وقت مال سامبل وحده هي تي اس، مو تمام؟ فاذا راح نجمع ال من السامبلات فنضرب ال في زمن السامبل الوحده، يطلع لنا ايش؟ الزمن المطلوب لجمع ال من السامبلات. هذا هو.
يعني هاي تي يخص سامبل واحد.
تي بوحدها هاي سامبل واحد. نعم، تي اس مؤشر يعني، شوفي مؤشر يعني بالرسمه تشوفين مسافه بين سامبلين، يعني هو تي مال سامبل وحده.
اوكي شكرا.
اوكي عفوا. Well, continue. Now we have discussed the first technique, which is the convolution table. Now let's go to the second way, which is called the linear time invariant form. As I think you are familiar with the delta function, it's okay. So when we talk about, say, x naught means what? Means multiplied by delta of n. When we say x1, it means that this sample is shifted by 1 to the right, okay? So it will be multiplied by delta of n minus 1. This one, x2, means this sample is shifted to the right by 2. So x2 multiplied by delta of n minus 2, delta of n minus 3, delta of n minus 4, and so on. Look, now we are going to represent x vector, I mean the input function, by the following. Look, x naught, this is delta function, delta of n minus 1, delta of n minus 2, delta of n minus 3, and delta of n minus 4. Well, this is the representation. Look, x of n becomes what? X of n delta of n, x1 delta of n minus 1, x2 delta of n minus 2, x3 delta of n minus 3, and x4 delta of n minus 4. Either using the matrix form representation, I mean single dimension, or we may use what? We may use a set of delta functions to represent the input signal x of n. Now, let's go to calculate what? Y of n. بس بناخذ رجاء. Now, y of n equals to what? Equals to x of n convolved with what? With edge of n. When we talked about the sampling, we said that if you are going to convolve any function with delta function, what will be the result?
راح يطلع الفانكشن ويا شيفت مال الدلتا.
بالضبط. اوكي، يعني نفس الفانكشن واذا الدلتا بها شيفتنج هي تشفت، ما بها شيفتنج تبقى as it was. Okay, so the result will be what? Will be the same function, but it will be shifted by the same amount of delta function shifting. Well, so I'm going to what? I'm going to apply the convolution for this term what? Individually. Say, just as imagine we have superposition. بس بناخذ الرجاء. X naught represents what? Represent a scale value, يعني constant, رقمه. Delta of n is a function. Okay, now delta function convolved with edge of n will be what? Will be edge of n, the same edge of n. Okay, so it will be x naught edge of n, the first term. Now, if you are going to perform the convolution with x1 delta of n minus 1, convolved with edge of n will be what? X1 edge of n minus 1, this one. Here again, we are going to perform the convolution between x2 delta of n minus 2 and edge of n will be x2 edge of n minus 2 and so on. So in this way, we have what? We have simplified the form of convolution. Why? We have followed the superposition to perform the overall summation. Well, now, by now we can what? We can reform the equation again. Now, y x the same form we have used. Okay. Now y will be in this form. Y will be x naught multiplied by edge naught, edge 1, edge 2, edge 3. Oh, we said that edge not, edge of n. Then we have edge of n minus 1. Okay, it will be shifted by 1. Edge of n minus 2, shifted by 2. Edge of n minus 3 by 3. And finally, it will be edge of n minus 4. And it will be shifted by 4. Well, now here we have the values of y. Now, by now, after doing that, we may reconstruct a new table, okay, or a new matrix by which we can calculate the convolution between these two signals. Please look at the table. I'm going to talk about very important points now. Now, I'm going to arrange the input vertically. بس بريخوبنا رجاءً. X is arranged vertically. Well, now edge is arranged horizontally. And in this example, I have added 4 zeros, okay? Or I have appended the edge by 4 zeros. Now the question is, why we have appended edge by 4 zeros, no more, no less, huh? بوشي مثلا ما نكري مثلا بين صفرة أو مثلا سي صفر. بوشي شار صفرة ما إضافة كرت بس.
Depend on why.
أري بوشي depend on why. Yes, depend on why. Why what? ايه چی تشتا واي درسته depend on
result ضربانه بجد بتم هندي ويلي بكن داد يدرس بما دركبت
ازاي ما چی تشتا هي يعني چی قانون هي بواي ها تشتك هي يعني who can answer the question يعني جماعة
واي ما حفظ به يعني
شو؟
معنى مود ان الواي لازم يكون 7
الواي يكون 7 لو ايش قد يكون؟
هو 7 المفروض
ناخذ واي كندا واي كند قيمة هشتن نا واي هشتن يعني طبعا انا بقى لك نيزكا طبعا راستي ليش متى بس بري خوب انتو بجميره يعني length of edge كا edge شنت قيمتها تيدا هاي شارن نا واكس شندا عفرم بينج بشار دبنا شند دبنا نه minus 1 هاشت عفرم اجبر هندي ما هي شار قيمتها الايدج عندي شو بكين دي اضافه كين شار 0 طبعا شنقو واي شندا شنقو واي هاشت قيمتها okay so we have to add 4 zeros y based on the equation of length of y equals to what? Length of edge plus length of x minus 1. Okay, don't forget this one. So this equation is very important where? In the LTI form. To construct the matrix of the LTI form, you have to have this equation. I mean, Ly equal to Lx plus Lh minus 1. It's okay. Now, let's go to the construction of the matrix. First of all, again, the same thing, very easy, very simple. X naught will be multiplied by the elements of edge, okay? So will be this first row. Second one, X1 will be multiplied by edge and then will be shifted by 1, okay? The whole elements are shifted to the right by 1. X2, again, multiplied by the whole element of edge and shifted by 2. X3 again shifted by 3 and finally X4 shifted multiplied by whole elements and shifted by 4 zeros. Okay, now what we are going to do now, we are going to perform the addition vertically. Well, I mean the elements available in the first column will be added together, second column added together, third, fourth, fifth, and so on, okay, up to reaching the last element in the LTI matrix form. Okay, this is the second way or the second technique by which we can perform what? We can perform the convolution. Is it okay?
ايش فرق بينه وبين بريده ما هذا شيء عاوز يقول تطبيق شيء درج به
يعني
او convolution table عاوز يقول وش يعني وصا خوب صفر ده يخن حتى هم بيتشيكن ما تفرق ده ما دي مشكله كبتها كما ما وتني تطبيق كان قصدي في
زانش تشتغل الامتحان احتمال بيجمته مثلا مثلا solve using LTI form مثلا. واحتمال ليش مثلا use the direct convolution method بس مثلا زاني.
سيدا
تمام
بله.
ما نسيتا في تيبلي ديريكا في چکن وقتی ما شفتین کبو نوع کیدی
دنقتنا واضحة بجارك طبعا بس دوباره كميز أحمد.
بيجم في تيبلي ما نوعی وقتی دی چکن وقتی ما شفتین کبو.
إيه تيبلان تو چكي
پا چی سیدایی دی ما وصانه چکر بو.
من قلت تما هاي دو أويدية هاي ما ركائي كي أويدية دايركت فورم نافيوي درسته يا دوي أفل LTI فورم يعني لازم تبصاني جوازية هاي ناف بيني دايركت فورم و LTI فورم. اوكي احتمال بيش مثلا ابي بما يعني تشيك باويدي بريكا دايركت فورمي او احتمال بيش مثلا using the LTI form ابي اشتمه هي ريكا رقم 3 اويديه matrix form. Now this is the example, numerical example. Now you are given x and h. Well, x and h, and you can construct the table and then add the elements in the each column. Okay, I'm going to find the sum of each column in the LTI matrix form. Okay, so in this way we can get what the result of y. Again, you have to do this example by your hand. Please, you have to take a piece of paper and a pen and try to do it by your hand, not just reading. Well, final form will be what? Will be the matrix form, okay? The convolution equation can also be written in linear matrix form. Y equals h by x, okay? Now we have what? We have a 2-dimension matrix will be multiplied by what? By a single dimension matrix, okay? So the rows of the edge matrix will be multiplied by the element of x. So in this time, the number of elements or the number of columns of edge must equals to what? Must equals to the elements of x. Well, edge naught, then we have edge 1, edge 2, edge 3, edge naught shifting by 1, shifting by 2, shifting by 3, and shifting by 4. Well, this will be the edge matrix, and just merely we need what? Multiplication between the 2-dimension matrix and single dimension matrix to get the single dimension y. This is another example, really. Again, edge x, this is edge matrix, and x matrix, and then the output will be the y. So we may change between x and edge, okay? Either making x matrix multiplied by edge or making edge matrix multiplied by x. Now we have another important topic, which is called the deconvolution. Okay, it's called what? The deconvolution. As I think, yes, 2 minutes left for this lecture. Please try to write down your names in the chat. Now we have another topic. Of course, after the rest, I'm going to continue with the deconvolution. But at the beginning, let us determine or define what do we mean by the deconvolution. Now, you know, we have talked about what about the convolution. We said that in the convolution, you have input and impulse response. Convolution between impulse response and the input will lead to what? Will lead to the output y. Now, practically, we have some cases. For example, the system impulse response is unknown, okay? The system impulse response is unknown. So how we are going to measure the impulse response of the system? For example, you are given a black box, okay? Black box, and you are asked to determine the impulse response for this black box, okay? What you are going to do, you are going to feed the input of this black box by an input X, well, and you are going to measure the output. Practically, say we have a signal generator at the input and the oscilloscope at the output, okay, and oscilloscope at the output. So you are going to measure the input and output. From input and output, we can what? We can guess edge of n using what? Using the deconvolution. Of course, this process is called what? Inverse filtering or system identification, okay? I mean, in this way, using the deconvolution, we may what? We may either perform something called inverse filtering or system identification. Okay, really, the deconvolution will be the title for the next lecture. Take rest for the 15 minutes, and then we are going to continue with the next lecture. Thank you very much.